Hey guys, this is Patrick from STH, and today we have something that is both crazy and super awesome all at the same time, and that is this thing. Now, if you don't know what this is the AMD EPYC 7H12. It is simply the fastest processor that you can go buy today. And let's be clear, when I say you can go buy these today, I don't mean like that is like, oh, I'm a data center customer, I'm going to buy 10,000 of these things or 100,000 of these things. I don't mean anything like that. If you have a high enough credit card limit, you can go out and actually configure a system and go buy it today. Now, these are semi-on roadmap parts, which basically means that AMD acknowledges that they exist, but at the same time, they don't really promote them in the same way that they do normal chips. I mean, in fact, we asked for AMD support for this video and they said absolutely not. But of course, because this is STH, just because AMD says you can't get this chip and we're not going to send you this chip, does not mean we are not going to test this chip because we will get one anyway. And I totally get why AMD doesn't want to talk about this chip too much because frankly, if people realized how awesome these chips are, and even heck, if you manage to get a discount over list price on these chips, then frankly, it would probably absolutely destroy the server market. And I don't even know if AMD with TSMC could even produce enough chips to be able to satisfy the demand if this thing was like a $4,000 or $5,000 chip. So in this video, and we'll have timestamps below, we're going to cover one, what the heck is this chip and what makes it so different? We're going to cover the performance and we're going to talk about two different scenarios. First, AMD EPYC 7H12 versus AMD, but then also AMD EPYC 7H12 versus Intel. And you're going to see exactly why Intel had to reduce the price of the basically Platinum 8280 level performance down by over 60% and get down to the Xeon Gold 6258R pricing levels. Finally, because this is STH, we're not just going to look at what this means for the server market today, but we're also going to take a look at what this means for the server market in 2021 when we see the next generation of both Ice Lake Xeons and also Milan, so the AMD EPYC 7003 series. There are a lot bigger implications than just this SKU. And before we get too far, I just want to go point out the fact that we do have an STH merch shop on Teespring. You can go down to the description and find our little store where you can go get cool merch, like this sweatshirt that I'm wearing if you want to be somewhat cool at least. All right, with an intro out of the way, let's take a look at what the heck this is. So the AMD EPYC 7H12 is a 64-core CPU that also has 128 threads. It has a 2.6 gigahertz base clock with a 3.3 gigahertz turbo boost. There's a full 256 megs of level 3 cache on board, but perhaps one of the most interesting features of this is the TDP. This is a 280 watt TDP part. For some reference, the highest TDP on any public Intel Xeon scalable second generation SKU, which is the contemporaneous SKU with this, on the public SKU side, they only go up to 205 watts. Now, there are other SKUs out there, but publicly it goes up to 205 watts, and this is a 280 watt part. The other kind of interesting thing about the system is that, well, it's not necessarily marketed to the general public, although it kind of is today. Back in 2019, when it was released, this was only a CPU that you could get if you're basically building a supercomputer or an HPC cluster. And so while this is technically a public and on roadmap SKU, AMD actually does not publish list pricing. Now, I went just before this video and I went to AMD and I said, hey guys, I know you're not supporting this video, but I'm doing it anyway. And I wanted a list price. And they said, nope, we're not going to give you a list price. And I said, okay, well, if you're not going to give me a list price, I can go see that if I go look on configurators, the basic street pricing is somewhere between $300 and $400 more than an AMD EPYC 7742, which is a $6,950, so $6,950 part. I said, could you at least confirm that in like 1K tray pricing, the unit price is somewhere around $300 to $400 more? And they said, yeah, that kind of makes sense. So we don't actually have a list price for this, but what that means is that basically in those high quantities, you could get these CPUs for somewhere in the $7,250 range to the $7,350 range. Sorry, I couldn't get you exact pricing. That's the best I could do. But looking beyond the 64 cores, there's way more going on here than just raw core counts and TDPs. I mean, we have a total of 128 PCIe Gen 4 lanes per CPU. And we recently did a video on a Dell system that can take two of these CPUs, and you can actually order these SKUs in that system. And you can actually get a total of 160 PCIe Gen 4 lanes in a system you can buy today, and you can just go order it from Dell. You also get 8-channel memory, and that's DDR4 3200 memory, which is something that Intel will eventually support with Ice Lake Xeons coming out next year. So we take just a second to compare at this point. This is a 64-core part that you can buy today. You have 160 PCIe Gen 4 lanes today, and Ice Lake will only have 64 lanes per CPU, so that'll be 128 PCIe Gen 4 lanes. So you actually get more PCIe connectivity potentially in a system today than you get with Ice Lake Xeons next year. And you have the same 8-channel DDR4 3200 memory that Ice Lake will bring. But the difference is that this is using a 2019 CPU, and by the time Ice Lake comes out, we will have a refresh to this part. We're going to get more on that on the Intel and AMD competition side, but oh my gosh, this is a absolutely huge processor. Now, if you simply want the fastest processor that you can go out and buy today because you're going to go build a big system, this is one you should definitely look at. But there are some caveats. Now, I mentioned earlier that this was specifically designed as a HPC system or an HPC CPU. Now, in the HPC market, something that is happening is that they are doing a transition very quickly, actually, to liquid cooling in the data centers that cool these HPC systems. And the reason for that is just as TDPs rise, not just on the CPU side, but also with the accelerators, they just need to go find a way to move heat out of the data center and cool things more efficiently. And so a 280 watt CPU, if you get into a high density situation, such as a 2U 4-node system, we reviewed the Dell PowerEdge C6525, and there they said, yeah, if you want to go put a higher end CPU, you can do that, but you need to go to liquid cooling, not air cooling like we reviewed. And there are a lot of other vendors, by the way, that do these 2U4 nodes, and you can go put a total of 8 of these CPUs in a 2U system. But I don't want to just actually focus on the HPC use case here. I want to talk about the broader implications of this chip because, well, the HPC market is relatively small compared to the broader market. Although 1U servers are generally considered kind of like the building block, these days with how much connectivity that the new CPUs and new platforms have, we tend to see that 2U systems become, very standard. I mean, most people know what a 2U server looks like, and those things you see in data centers all the time. And in a 2U server, you can actually cool a 280 watt CPU because you can get enough airflow through a taller heatsink to be able to cool something that is putting out 280 watts in that little footprint of a CPU. And if you want to know why there's kind of a difference between, well, in a normal 2U system, you can air cool these, but in a 2U 4-node system, you can't air cool them. It doesn't just have to do with the total power consumption. It's actually being able to remove enough heat from a certain surface area, which is basically the top of a chip, and how fast you can do that with heat sinks. And so that's why we see liquid cooling on the more dense solutions, but on the air-cooled 2U standard systems, no problem. And being able to configure these CPUs in a 2U system means that you can get access to the absolute fastest processor you can buy today in a standard form factor. So let's talk a little bit about performance because we're going to do this really in 2 parts. So I'm going to talk a little bit on camera about it, but we also have the STH main site review where we're going to go into more numbers. We're going to go into more detail on some of the numbers, but I want to just kind of flash up a couple comparisons here because I think that's a really important aspect. And really the only reason that you buy this is because you're looking for that maximum performance. And let's start with talking about AMD to AMD. Now, AMD has a number of 64-core CPUs out there, but I really don't think that most of those are ones that we could compare easily to the AMD EPYC 7H12. I think the only one that really is worthwhile to compare is the AMD EPYC 7742. Now, the AMD EPYC 7742 is a 225 watt part, but you can actually configure the TDP up to 240 watts. Now, if you have a system that's a 2U system, a lot of the early ones even were able to handle that higher 240 watt TDP. So you could actually go and configure that 240 watts. And literally it's just a BIOS setting and you switch the BIOS setting, say, yep, you can run up to 240 watts. The system will use more power, but you get, maybe 2-3% more performance out of it. If you have a system that can cool the higher TDPs, there are some processors that AMD sells that you can actually configure up to a higher TDP level, which gives the cores more breathing room to basically run at higher turbo clocks and run faster, longer. Now, the AMD EPYC 7H12 is kind of like that, but just the next level. Instead of just going up a 15 watt increment to 240 watts, we go up another 40 watts to a total of 280 watts. And all of the systems to be able to support this chip need to be able to support a 280 watt TDP CPU. So there's no question of, well, can I go configure that extra bit? Because if you can configure it in the system, it has to support that 280 watts. Now, when we ran these AMD EPYC 7H12s in the PowerEdge R7525, we got some decent performance. And then Dell said, hey, by the way, now that you're done running all your benchmarks, we actually have a little BIOS that is going to increase your performance. So why don't you go use this instead? Thanks, Dell. So we had to go rerun all of our numbers. Now, something that's really important is that the 7742 numbers, we're using the AMD Daytona system, which is it's built by Quanta, but they don't want to say that, but it's built by QCT for AMD as their kind of development reference platform. And we're comparing that to the Dell R7525, which you can just go out and buy. That also means that there's going to be a little bit difference in terms of cooling. And so we're just going to have to say that that's what we're going to have to live with, because we cannot take these AMD EPYC 7H12s and put them into that Daytona system, because they are AMD PSB locked. Dell actually vendor locks their AMD EPYC CPUs now. And so that is something that we want all of our readers to go look at. We have a video on that, so go check that out. Okay, with all these disclaimers aside, how does it perform? And that's a great question. So the AMD EPYC 7H12, if you're going to flash a whole bunch of charts up here, it actually performs a lot better than the AMD EPYC 7742. I mean, it doesn't necessarily seem like a lot because we're just looking at little tiny increments of bars, but these increments are often pretty darn good. And the reason we see this additional performance, even though we have basically the same underlying cores and cache structures, modern CPUs are so advanced that they're able to sense how much power they're using. They're able to conform their performance to certain power and thermal limits. And with this CPU, we actually get a little bit higher than we do on the other parts. But there are actually two parts to this that I think that are really important to kind of cover. And the first part of this is that if you look at how an AMD EPYC 64-core part is constructed, there's still that same I/O die in the middle, but then there are a total of 8 CCDs that have all your x86 cores that sit around the periphery. Now, between the AMD EPYC 7742 and the AMD EPYC 7H12, that I/O die basically stays more or less static, while the performance and the clock speeds of those CCDs increases. So as we get more TDP, it's not just that the whole chip is going to necessarily clock up and it's going to use the power and thermal headroom from that. It's actually the CCDs that are mostly going to get that benefit. So as we raise TDP, we actually get these cores to be able to hold higher clock speeds longer. And in an HPC application, that's exactly what you want. You want to be able to load your cores up and just run them at high frequencies as often and as long as you can. The flip side to that, of course, is that as you go run at higher clock speeds, you're less power efficient. So it's not necessarily a linear scaling that you get as you go from 225 or 240 watts up to 280 watt TDP, but you still get a lot more benefit than one might think, just because you're not necessarily incrementing the power consumption and TDP of that I/O die. Also, just in our AMD versus AMD discussion, somebody's going to say, wait a sec, what about the Threadripper 3990X? Doesn't that have higher clock speeds and a similar TDP? And the answer to that is yes, it does. But I would argue that the 7H12 makes a much better server processor. I mean, we get RDIMM support, so we can use much higher capacity memory. We get the full PCIe Gen 428 lane layout that we don't get on the Threadripper side. And the Threadripper 3990X is only a single socket part. It's not dual socket capable. Now, AMD does have the Threadripper Pro, which we're super excited about in some limited quantities that does support things like ECC RDIMMs, but it's not necessarily the same level that we get in a EPYC chip. For a mainstream server, that Threadripper part just simply doesn't work because it just doesn't scale like these EPYC chips do. We do wish that AMD one day went and addressed this, but well, it is what it is for right now. Then we get to the AMD versus Intel comparison, and things get just straight wonky. I mean, the closest thing that Intel has to a EPYC 7H12 is the Platinum 9200 series, which basically takes two Cascade Lake chips, puts them onto a single package, and then solders that package onto a motherboard. You don't get the full PCIe connectivity of having two chips. You don't get the same memory capacity. You don't even get Intel Optane DC persistent memory support, which is one of the big features of Cascade Lake. You don't get that with Cascade AP. And something that you're seeing is that although we saw some initial optimism around the Platinum 9200 series, now basically nobody's talking about it and it's not winning a lot in supercomputers. So we're pretty much going to say that that's not really a comparable part. Also, because the Platinum 9200 series was soldered onto the motherboard, you actually had to use a standard Intel form factor, which means that OEMs couldn't go design their own platforms and boards because it wasn't a socketed part. But technically, that is the way that Intel is competing against these systems today. And you could also say that maybe Cooper Lake would be an example because you could have a 4-socket system. Maybe that is a competitive part. We might do Cooper Lake on STH, but I'm still kind of working on that. And if we're talking mainstream servers, remember that this part came out of a Dell PowerEdge R7525 that you can just go buy online, not some kind of special HPC part. If we're talking about mainstream servers, then basically you're talking about your competition as the Intel Xeon Platinum 8280 right now, or the Intel Xeon Gold 6258R. Now, the 6258R is the refresh part that was launched earlier this year. We have a video on the whole refresh if you want to go look at that. And what Intel basically did was that they dropped the price of pretty much the same level of performance of the Platinum 8280 down about over 60% to what we get now as the Xeon Gold 6258R. 6258R is a 28-core part. It does have higher clock speeds, but at some point you just kind of run out of headroom when you only have 28 cores. Furthermore, that only has 6-channel memory support. It does not have DDR4 3200 support, so you get way more memory bandwidth with AMD EPYC. The Xeon Gold 6258R also has only 48 PCIe Gen 3 lanes instead of the PCIe Gen 4 lanes that we find on the AMD EPYC part. We're going to talk about that platform expandability in a second, but just if we look at performance, we get pretty much the performance that we would expect. The Intel Xeon Gold 6258R is just nowhere even in the ballpark. In fact, when you look at CPU performance, I would argue that you actually see performance that's more akin to something like half the performance of an AMD EPYC 7H12. And what that practically means is that organizations can look at doing consolidation of servers by a 2-to-1 ratio over the highest end Intel Xeon system that you can buy today. Of course, this is all going to change next year, but both AMD and Intel are going to have new parts. But even today, you could buy half the number of servers by going AMD EPYC 7H12 versus buying the highest end Intel Xeon processor you can get for mainstream sockets. That's absolutely insane. But CPU performance is really only one aspect to this entire thing because there's another story, which is the expandability. Now, the Intel Xeon Gold 6258R only supports up to 1 terabyte of memory. And in systems like this, especially if you're thinking about, well, can I consolidate on a 2-to-1 basis? Well, if you did want that, you'd probably want to have twice the memory that in the AMD system that you had in the Intel system because, well, that's kind of how you would consolidate. And usually memory capacity is actually a big deal. And on the Intel side, it's actually a little funky even getting to 1 terabyte because you have 6-channel memory or up to 12 DIMMs total. Whereas on the AMD side, you have 8-channel memory or up to 16 DIMMs total. And since AMD isn't artificially limiting the amount of memory that you can potentially use, that means that you could use things like 64 gig DIMMs, and you can get a 1 terabyte per socket very easily. And you don't need a funky configuration. You can just use standard DIMMs. The other thing that these AMD EPYC parts can do is you can actually go buy, now these things are not cheap, but you can go buy 256 gig LR DIMMs. These things will cost you at least maybe $2,000, $2,200, $2,500, somewhere in that each. But if you really want to go up to something like a 4 terabyte per socket, you could do that in these AMD parts using DRAM. You don't have to go to Optane. On the PCIe side, the Intel Xeon Gold has 48 PCIe Gen 3 lanes, which I guess is good, but those are PCIe Gen 3 and there's only 48 of them. When you put 2 in a system, you get a total of 96 PCIe Gen 3 lanes, and we compare that to the 7H12. The AMD EPYC 7H12 has 128 lanes standard in a dual socket configuration of PCIe Gen 4, but we did a video on this as well. You can get up to 160 lanes of PCIe Gen 4. And so if we just compare raw connectivity, and I mean just how many devices you can put or how many PCIe lanes you have, you basically on a dual socket AMD EPYC 7H12 system have as much PCIe or as many PCIe lanes as a total of about 3 1/3 Intel Xeon processors. So it's not necessarily 4 of them, which will give you a 2-to-1 consolidation ratio, but it's not that far off. But the actual lane connectivity is super important, but it's only half the story because you also have things like PCIe switches, so you can expand that. And you have PCIe Gen 4 versus PCIe Gen 3. So all of those lanes are actually give you twice as much bandwidth. And what that basically means is that you have the bandwidth potential as about 6 2/3 Xeon scalable 2nd generation processors. Now, of course, there are practical limitations about actually using that much bandwidth, but you do have the connectivity to be able to go put a whole bunch of devices onto a system and be able to connect them at high speed. So from a consolidation standpoint, we have more than twice as many cores. We have more than twice as much memory capacity. We have more memory bandwidth, and we also have the ability to do a lot more PCIe connectivity and have more PCIe bandwidth. When I say that these CPUs are definitely 2-to-1 consolidation over Intel Xeon systems, they completely are. And our test system with these AMD EPYC 7H12s, the list price on it is over $110,000. Even with just standard discounts, you're already down into maybe the mid $70,000 range. So this is not a cheap system, but that just goes to show, these CPUs are actually not a huge percentage of the total system cost, even at, a little over $7,000 each. They're actually not even like a 25% line item in the total system cost. And so when we talk about consolidating from 2 Intel Xeon systems into one AMD EPYC system, you can see why that is such an attractive model, because the cost of the system is not just the CPUs, it's actually the cost of the entire system. All right, so this is going to be a really long video, I have a feeling. But let's talk about the market aspects, because I think those are also really important. So first off, 64 cores in a modern processor is just frankly too much. The reason that the 64 core parts are not as popular as some of the lower end ones, like the 32 core parts, is just simply that the market looks at it as like, okay, that's cool that you have 64 cores, but I don't necessarily need that many cores. I'd rather have fewer higher performing cores for some, per core license applications. So we looked at the AMD EPYC frequency optimized SKUs, and we can link that in the description as well. But even on the HPC side, these are not necessarily the ones that everybody wants. And since the HPC market generally works on things like bandwidth per core, maybe TDP per core, something like that, those kind of ratios, they don't necessarily need a 64 core part. A lot of times they can get away with things that are lower core counts and just scale out the number of systems. There are costs involved with scaling out as well. And so it's just a balancing act that the HPC guys have to go do. The same thing happens in standard data centers. If you have a normal virtualized data center or Kubernetes cluster that you're building, then you basically have to look at things like, well, how much CPU do I need in relation to the amount of memory bandwidth, amount of storage, and networking connectivity that I have. Also maybe accelerators if you have GPUs. And so as much as I absolutely love this chip, I think it is groundbreaking, phenomenal, and I really wish we would have been able to do this piece a lot earlier in the product cycle. It's not the right answer for everybody, but it does inform what we can talk about in terms of the systems of tomorrow. Because this is a 280 watt TDP CPU, which may seem like a lot if you're coming from a view of like 2019 or something like that. But in the 2021 landscape, a 280 watt TDP CPU is going to be more commonplace. And so those discussions that we had earlier in this video around how we need liquid cooling for things like 2U4 nodes at the high end, this high end SKU versus we can still cool them in the 2U systems, that's going to become more prominent and more prevalent of an issue and a breakpoint in the future as we get to higher TDP CPUs. Even on the GPU side, we're already seeing that. We did the 8 NVIDIA V100 piece earlier this year. And when we're going to go do the A100 piece, I can tell you that that system is using a lot more power than we saw in the V100 system because, well, our GPU TDPs rise. Also on the networking side, we're seeing TDPs rise as we get things like SmartNICs and we also get DPUs. And so your networking power consumption is going to rise as well. So CPUs are rising in power consumption, but they're really doing it in line with everything else that goes into your system. What I can say is that for our readers, that if you do have to go and buy servers for the end of the year because you're thinking, well, I got to go buy something or else I lose my budget or something like that, you should go look at the AMD EPYC 7H12. For a lot of you, the AMD EPYC 7742 is going to be the better option just because it is more flexible in terms of configurations and the types of systems you can put it in. But if you're just buying 2U servers, the price premium is actually not that much, and getting, a couple percent, 5% or whatever better performance out of a $70,000 box is actually pretty worthwhile if it only costs somewhere between, say, $600 and $800. Now, of course, go check out the main site article because that's going to have a lot more detail. And I know a lot of you guys are going to want to see more performance details. Go check that out. And I really hope you like this type of content. We're going to do more of this stuff on STH. We have some just massive systems. I mean, literally, I got a system the other day that was on a pallet. It was a single system that weighed 410 pounds, or I think it's like 186 kilograms. The thing was absolutely massive. And that's going to be a future review that we're going to have probably this quarter on STH. We have a lot of cool stuff in the pipeline, and so why don't you click that subscribe, turn on those notifications so you can see whenever we come out with a great new video. Check out the STH main site every day because we have something new there. And as always, thanks for watching and have an awesome day.